What are solid principles? Below are the 5 solid principles, where solid stands for, S stands for, single responsibility principle. O stands for, open/closed principle. L stands for, Liskov substitution principle. I stands for, interface segregation principle. D stands for, dependency inversion principle. 1. Single responsibility principle, SRP. This principle states that a class should have only one reason to change, meaning it should have only one job or responsibility. Why it matters? This principle helps in creating classes that are easy to understand, modify, and test. If a class has multiple responsibilities, changes in one part of the class could affect others, making maintenance harder. Example: a user manager class should only be responsible for user management, like creating or deleting users, not for tasks like sending emails or logging activities. 2. Open/closed principle, OCP. This principle states that software entities, classes, modules, functions, should be open for extension but closed for modification. Why it matters? It encourages you to add new functionality without changing the existing code, which minimizes the risk of introducing bugs into well-tested code. Example: instead of modifying a class when adding new behavior, you can extend it or implement new interfaces. 3. Liskov substitution principle, LSP. This principle states that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. Why it matters? It ensures that a subclass can stand in for its superclass and that the system behaves as expected. For example, if you have a bird class and a penguin subclass, a penguin object should still behave like a bird, that is, it should still be able to perform the fly action if penguin can. 4. Interface segregation principle, ISP. This principle states that a client should not be forced to implement interfaces it does not use. Why it matters? By breaking down large, general-purpose interfaces into smaller, more specific ones, you make it easier for clients to only depend on the methods they need. This reduces unnecessary dependencies and keeps the system more maintainable. For example, a worker interface should not include methods related to manager responsibilities if a class implementing worker does not need them. 5. Dependency inversion principle, DIP. This principle states that a high-level modules should not depend on low-level modules. Both should depend on abstractions, for example, interfaces. Furthermore, abstractions should not depend on details. Details should depend on abstractions. Why it matters? This principle decouples high-level business logic from low-level details, which makes it easier to modify and extend the code. You can change the implementation details without affecting the high-level code. For example, instead of a report generator class directly depending on a CSV exporter class, it could depend on an abstract exporter interface, allowing you to easily switch between CSV, XML, or JSON formats without changing the report generator. By following these principles, your code becomes more modular, easier to test, and less prone to bugs, which is especially helpful when working in large and evolving software systems. Thanks a lot for watching the video till end. Please subscribe to my YouTube channel.